Hi guys, welcome to Learn Electronics Repair, and today I have something different on my bench. So these are stage or club lighting. Well, I say club here, that probably means on the beach at night. I have two of these and they're both doing the same thing. Now the guy who brought them in says they're faulty, but from what I understand he's got these from somewhere. These are not like he was using them and now they don't work. He's acquired these from somewhere and they're actually both doing the same thing. And I will say straight away, I'm not totally convinced these are faulty as such, but we'll see, hopefully. So let me show you what these do. And these are not the easiest thing to fit on the desk, as you can see. So we'll switch on. The lights flashed. I hope you can see that. They all flashed. And now on here it says beam rest. Beam rest, okay. And the buttons don't actually do anything. Now if we wait. That. And did you see this one here at the end isn't kind of following all the others, okay. I'll just put it so you can see the display hopefully. This has a noisy fan by the sound of it as well. Just switch it off. Yeah, they've all come back up on their own. So when it first moves, the lights actually flash. I'll just try and hold this here so you can see. Yeah, there you see it. Okay. They all go into position. And this says beam rest. And if we don't touch anything at all, rather than pressing the buttons. There we go, yeah. They all moved, it flashed off on, still says beam rest. Okay, so that's what it's actually doing. And then when you switch off, they all go into the home position, okay. Here's the other one. Let's get where you can see it all again. So power this one on. Same thing. It says beam rest already, by the way, even before they start to move. Wait a little bit. Yeah, and again, this end one doesn't seem to move. These do. It moves a little bit, okay. And back to there, it still says beam rest. We can press the buttons or hold buttons in. So I'm holding button, menu in, enter, try combinations. Doesn't seem to do anything. Now the guy who owns these seems to be convinced that these should have 3 modes, okay, and that's common for stage lighting, but it doesn't have to be. So apart from the very cheap things you can buy which are just sound to light, normally these will have auto mode, which goes into kind of a pre-programmed show. They will have sound mode, which is the same as the auto mode, but it synchronizes with the music, beats of the music, okay. And they will have DMX. So DMX is a protocol for controlling stage lighting, and DMX uses these connectors, so you'll have in and out. Now in the DMX mode, you can normally configure one of the lighting units to be the master, which is usually done with dip switches, but it could be done in the menu, and other devices can usually be configured to be slave. And then when it goes into the auto mode or the sound mode, they will all synchronize together. Now I will mention, because I have done some work on this, especially at mobile discos in the UK, that although DMX is designed to control stage lighting, when these things go into the auto modes, they don't actually use DMX. They use the same connectors, so you daisy chain them together, but they actually use a serial protocol to do it, which is much faster. So we need to answer, really, what are these supposed to do? That beam rest, does it just mean it's in standby? I don't know. I thought, is it reset? But I don't think it is. I'm not sure how many digits we can actually get on that display. And the problem I have there is there's no markings on these things anywhere that actually say the make or a model. There's absolutely no information on them whatsoever. So I don't actually know what they are. But it seems strange that I can't get into the menu. So normally in the menu, you would be able to get into there in any mode. I think you'll agree with me there. And these seem to be locked out or something. So, two things. First of all, I want to chat a bit about DMX. Explain to you how this protocol actually works. It maybe works not the way you would expect. I'm not sure how useful this is in repair work, but it's interesting, I think, so I'll tell you how the DMX works. And then I think we need to figure out what these actually are. I mean, there's a hell of a lot of screws that hold them together. Maybe there's some markings on the PCB. I'm going to try just taking a photo of this and giving it to the AI and say, what is that? See if that knows, yeah. And if we can find out what these are, then hopefully we'll find a user manual and be able to figure out what's actually going on with them and if they are actually faulty. Another thought I have is maybe that because these are quite greasy and sticky, they probably have some sort of optical sensors in here, little discs effectively. Okay, optical sensors. This rotates, by the way. Yeah, 1 3/4 times, okay. So we could just have some optical sensors covered in grime. That's another possibility, which is maybe why it can't detect the position of the lights or all of the lights. So that's another thought. Maybe it's that sort of problem. Okay, so anyway, DMX. DMX. Digital multiplex. Okay? And basically with a DMX, you'll have a controller, master, okay, and then cable. So these cables are XLR cables. These sort of cables, okay, XLR, 3-pin. But not all of those XLR cables you find are DMX cables, because some of them are microphone cables, okay, and the microphone cables have 2 of the pins connected together. So there's actually only 2 connections, and the DMX cable needs all 3, okay. So just bear in mind, if you're messing with this stuff, if you plug a microphone cable in, the DMX won't work. So we have the output from the master. And we have, of course, a slave in, okay. This is usually a light, but it could be a fog machine, pyrotechnics, you know, all the things that you can have on a stage, really. And out, and that goes to the next slave, okay. We'll just draw 3, in, out. Here's another slave. Okay, and the master can control the slaves. Now, the master could be a computer. Yeah, it could be one of the lighting units itself, which is controlling others in the same line. We won't call it a line. Actually, this group is called a universe. Okay, it's called a universe. And each universe can have up to 512 channels, not lights, channels. Okay? And the controller may be a single universe, it could be multiple universes, depending on the complexity of the system you have. Okay? So manual sliders, or more often something controlled via a computer, sometimes controlled via MIDI from a computer, but you get the idea, yeah. So each of the slaves can have 1 channel, many channels, okay, sometimes combined, so putting a value on 1 channel and then varying another one. So for example, one to turn an aperture to open, another one to vary the size of the aperture, that sort of thing. So the variation of size only works if the aperture is on, or one to control an aperture and one control a strobe to control colours, and each effect needs at least 1 DMX channel. Okay, So imagine this is an RGB light, okay, red, green, blue. So typically this would have 3, maybe 4 channels. So you would have one channel which specifies the brightness of the red LED, for the green, for the blue, and you'll probably have another one which is strobe. So strobe can either turn all of them off, or it can actually strobe the light. And there's other possibilities. It could have 6 channels, strobing ones individually. I mean, there's lots of possibilities here, okay? But that light, let's say it has 3 channels. So that will take at least 3 addresses. Now, the address can hold a value, or rather the data. So you have the address, which addresses the data, okay? The data can be anywhere from 0 to 255. But you could have, if you had a very fancy light that needs 65,535 combinations, you can have 2 addresses for each LED, okay? And then you could have from 0 to 65, I think it's 65356. I'm not even going to look it up. I'm probably wrong. Anyway, whichever one it is, yeah, a long time I've had to work that number out. Okay, somebody's going to tell me what the real one is, but the point is, it's not really relevant to this discussion. So, let's say this needs 6 bytes of data, yeah, to control each LED. And this also needs 6 bytes of data, yeah. And this is something else completely different. So each slave device has an address. So typically this first one could start at address 1 to address 6. Yeah. So you would set this on the light using dip switches or in a menu. This one would then go from 7 to 12. Okay. And this would, however many it uses, however many channels, it could be something completely different. And now the controller, the master, can control each light individually, or it can send on the same data, okay? And I'll just mention, because I missed it, the full name for DMX is actually DMX512, okay? And I'll also mention that on older fittings, you may have a 5-pin connector rather than a 3-pin. Now, how does the master address the slaves? Well, it doesn't exactly. The slaves happen to know what address they are on. The master doesn't know what device is on what address. Okay, so what happens is we have an idle level, voltage high, okay, and we have a pulse, which is the start pulse, okay, and then we have the bytes of data. So we have inside of each of these, we have bytes of data. It uses a serial protocol with a start bit, 8 data bits and 2 stop bits. It's like serial communications, okay? And each one of these bytes is an address, but the bytes don't contain the address. Quite simply, whatever is in the first byte, this is address 1. Whatever is in the second byte, that is address 2. Whatever's in the third byte, address 3, and so on, up until address 512, okay? So what the slave does is, this slave knows it's set on address 1 to 6. So after the start bit, it just takes the next 6 bytes, 1, 2, 3, 4, 5, 6, and ignores the rest. This one knows its address doesn't start till 7, so when it sees the start bit, it ignores the first 6 bytes of data and gets the next 6. Yeah, 7, 8, 9, 10, 11, 12. And then this, if it has 15 channels, would ignore the first 12 because it starts at 13 and goes up to, what's 15 on top of that, 28. And it will take the next 15 bytes of data and then ignore the remainder. So that's how the addressing actually works. There's one upshot to this, by the way. You don't have to set the addresses of the devices consecutive like this. They can be anything as long as they don't clash with each other. Okay. But if you were, for example, to set this one to address 1 to 6, 7 to 12, okay, and then set this one like 420 to 400 and what was it, 448. Yeah. What the controller now has to do, it sends the first 12 bytes of data. It now has to send 408 bytes of empty data because there's nothing on those addresses to address that one. And because it's now having to send a much longer string of data, it slows the refresh rate down. Yeah, so you should always keep the addresses as low as possible and consecutive like that, just for refresh rate. Okay, so that is basically how DMX works. As I say, it's not that useful for repair work, but it's interesting, don't you think? Now the question, what actually are these and are they faulty? Okay, so I asked the AI. I'm doing this a lot these days. Yeah, seems to be, well, progress or something. It's the future. Yeah, I've used it. It's the future. So AI says, ask me for some photos of the panel. It says beam rest. Yeah, and the connectors. Tells me it is one of the many generic DMX spider type bars or spider bar types. Gave me some brands they are sold as. Okay, it's one of those. Tells me why. It tells me how to get into the menu, or I should be able to, by pressing certain buttons. It says it's not an error, by the way. It stands for beam reset. Suggests I use a DMX controller. I don't have one. I'm going to buy myself a cheap one. I'll probably see more of this stuff in future. It's worth it to me. Okay, so I'll get one. Or I'm sure the customer actually will have one if I need to borrow it. Okay. Suggests waiting 15 seconds after beam rest and press menu, but it doesn't do anything. I've tried that. And then you should go through the various modes. Yeah, which is what I thought it would be. Hold menu plus up while powering on. Forces a default reset to auto. It doesn't do anything. Menu plus down. Doesn't do anything. Says the processor may be hanging because it expects the DMX input. Seems a bit unlikely. I think this is more likely. The keypad connector may be unplugged or the button board is dead. Okay. On both. Yeah, fair enough. But yeah, dust and grime and stuff here wouldn't surprise me. So it says it's most likely working, apart from the buttons. So I'm saying menu up and down, menu plus up, menu plus down, no effect. Waiting 30 seconds from power on, no effect, blah, blah, blah. And the next thing we come to basically is to have a look to see if the ribbons disconnected of the switches actually work. So let's do that. And maybe inside we might have an even better idea who made this. So, as is often the case here, these screws are all rusted. Okay. They were difficult to remove. I actually ended up having to drill two of them out at one end. And then there isn't exactly a ribbon cable. Well, there's two, but they're little cables, not ribbons. One of them goes, yeah, to the DMX here. So this is the DMX. And the other one here for connection, so SPI, something like that. The fact the display works pretty much tells me the communication here is working. I mean, it would be strange the display works and the buttons don't, but the buttons themselves could be bad. Let's have a look. So we can see, yeah, these two are connected together. And these two connect together. So if we measure across the switch and then we'll try and press the button. So yeah, it's like a diode. Well, that button certainly works, so yeah. Yeah, the buttons all work. That was like a microphone, actually, for the auto sound operated mode. XY191, what else do we have in here? So these are driven by belts, you can see. So we have a stepper motor which drives a belt which turns these, and then there must be something inside here, another motor or something. Yeah, it looks like, without unravelling all this lot, as this one is controlling two stepper motors. Okay, and this one, which is identical to that one, is controlling 2 stepper motors, and then the other one in the middle I think is controlling the vertical position of the 4 heads, because that board looks different to the others. Okay, so that's what we have: control boards each individually, and then switch mode power supply, 2 power supplies actually, so one for the lamps and one for the logic of this and the motors. And it may be in actual fact that this is controlling everything else. MA803AS2, and then some other numbers. Yeah, this thing, MA803. So this is a microcontroller. This is all in Chinese basically. But I can see things like RAM, flash, watchdog timer. Obviously the Chinese don't have any words for these things. CPU, yeah, PWM. Yeah, we can see a block diagram with RAM register, stack pointer. This is a microcontroller, and this is the LCD panel. So this is one unit basically. So in actual fact, I'd say that that is controlling everything. And then this cable here, SPI, will go down to all of these boards, so it can talk to all of them, address them, talk to them, and drive the effects. So this is the brain of it. So the idea of having a ribbon cable problem between the MCU and the display board is not even a possibility on this one. The other 2 chips, well, that's an LM358 dual op amp, 75176, something similar I think. And I don't see any other ICs on this side. There could be down there, I guess. So there could be an EEPROM, or this may just have its own flash memory. Oh, the 75176 is a differential buzz transceiver. That makes sense because DMX uses differential signals. Yeah, so that's probably for that in actual fact. Yeah. Another thing I've noticed, I'm just going to show this actually like a recording I made of this because I couldn't see it. But while it's saying beam rest, before the lamps reset the second time, I was seeing the message flashing up on the screen, and it was so fast I couldn't read it. So I recorded it and then effectively just freeze frame. So if we just get to where it happens there, okay. And it actually now says DMX mode. But then after some seconds, you're supposed to be able to go into the menu and choose auto or sound mode. So I'll just move these. You can see in actual fact, I just turn them around a little bit. Okay. That when it does the reset, it actually does it in both axes. Let me just show you now. Okay, so they all move to the end stop there and down. Okay, this is beam rest. Wait a little bit. Now you see this one doesn't come up all the way. Okay, and the other one does the same with exactly the same one. And it was at that point when this actually says DMX mode. But if I switch off, this then goes back into its position properly. Okay, so they're both doing the same in that respect. One possibility here is that when it's doing this beam rest, which is normal, and it's normal to do it twice, there would be sensors, I'm guessing, so it knows when it reaches the end of the movement. And maybe if one of those sensors isn't working, yeah, it might think it's not resetting. That's why we can't go any further. So that's the next possibility. The problem I'm having here, honestly, is like lack of information. I mean, it's kind of put a finger in the air, you know, think, well, what's the most likely thing next? Okay, so that's the theory I'm working on at the moment. If we can see that reset thing coming back, then maybe we can actually prove or disprove this. The problem is that there are 3 PCBs. One does all of this movement, and the others are a pair for these, on each PCB for the stepper motors. And I don't know which one if any, or if multiple ones have a problem with the reset, if even that's the problem. Usual sort of thing I'm faced with, but let's see if we can get any further. And just to complicate things, I don't actually know if that really is what's happening with this. Maybe for some reason it's locked into DMX mode, although trying the menu up held and when powering on, which is supposed to reset it, didn't seem to do anything. I don't have a DMX controller here. I can get a DMX dongle. However, the very nice AI explained how to use an Arduino as a basic DMX controller to test this, and even gave me a sketch to do so. So those are things we could possibly do. But let's have a look at this sensor theory. There are a whole bunch of wires which go up here. Okay, rather a lot of them. Obviously, some will be controlling the lamp. Some will be controlling this rotation and possibly sensing. But whatever is going on will be going on inside this. And we can actually get the covers off. So there's screws in here and screws in there, and then there's, you can't see them, but the screws under this cover. So as long as they're not all seized up, we can get these covers off and see if we can see like a micro switch or something like that. Maybe an optical disc, like a round thing with graduated lines etched into it. Something like that. Okay, so there's a bit of a struggle getting this one off, but I don't think anything's actually down there. I would have to undo the screws in this bottom thing. Yeah, I can get at them. Yeah, we may as well check. This is where you need the right tool sometimes, guys, yeah. Couldn't get in there with my other screwdriver. Okay, something is stopping me from getting this piece off. It just seems to be caught at one end somehow. Oh, now I see it. Okay, there were two more screws at the bottom for that cover as well, but it's off now. So this is the actual LED, 4-color. Not sure that's good. It looks a bit burnt to me. Okay, we can test that. Don't suppose that would stop it from resetting, do you? This is where the wires come in, so just try to get an angle for you guys. Yeah, this is my webcam, so not as clear as the other one, but all the wires come up there, they go through here, and then they go back in through here. Okay. We have a bunch of them here on the LED, okay, and they are marked red plus, green plus, blue plus, white plus, and then minus for each one. That's a bit unusual. Normally you would have just like a common terminal plus the other four. Okay, maybe one end are actually connected together. Probably the plus end, if they are, you would normally switch to the minus end. Don't like the look of that. So there's 4 wires and 4, that's 8 wires going that way. Then we have the stepper motor with 4 connections, and now you can see how the sensor works. There's a disc here, yeah, that thing, and at the bottom of it, yeah, this. So this little metal bar is slightly in the way, but you can see the disc actually rotates through this device. And this is a sensor, so this is where it actually detects when it stops moving, I would say. When it knows where the end stop is, yeah. See there. Very difficult to get a good angle for you guys on this. There, different camera, that probably helps. Yeah, so you can see, okay, and there's actually 2 sensors here. So there'll be 2 LEDs and 2 photo transistors. And it will be able to detect, due to the spacing of the holes compared to the spacing of those, not only the speed of direction, but which direction it's moving, okay? So that's how the sensor is done. And that comes back down these wires, so these 4. Okay, so we could determine if the sensor is actually working with a scope when it moves. Not at this end, because this end is moving, but we find the other end of those wires. If we get the PCB out from the unit, hopefully the wires are long enough, we could do that and we could monitor all of them. And these have the same arrangement we can see now. So these are the sensor wires and these are the opto sensors. So yeah, it shouldn't be difficult to figure out if all the sensors are actually working. I was thinking maybe they would be gummed up with dirt. Doesn't surprise me here. Everything gets gummed up with dirt here, but you don't look bad, to be honest. The actual motor, well, that's here. So it's actually belt driven. Yeah, you can see the belt. Okay. But the first thing I'm concerned about is these LEDs. Are they any good? Let's have a look at these LEDs, see if we can test them with our meter. So, white. Wow. I may have to unplug it from the control. I wouldn't have thought so though. Let's try. Blue. Green. All look like capacitors charging to me. I'll just disconnect all the wires that go to this. And that was fairly easy because they just plug into the board down here, okay? Now, what do we get? Red. Green. Although it's the blue wire, but it does say green there, okay. Blue, white. So they do work. Blue's a bit dim. What's the voltage drop? So 2.54, 2.45. Then these should be lower. Hence the fact they'll be brighter. 2.33. 1.65. I could give these more drive using my bench power supply, put a resistor in series because of the initial inrush current from the capacitor and the supply. So I could test them better. I'd probably have some LEDs like this actually. Yeah, I have a pack of these. So in actual fact, if you look at it, I'd say this isn't the same layout, and this is a 12 watt, and I believe these are 10 watt. Okay. But we do see like a dark one there, kind of like a yellow one. Well, that's there. Let's see how well this one lights up. I'd say it's brighter. Yeah, much more evenly illuminated when compared to this one. Red is about the same as that other one was. Green also. Blue much dimmer. Yeah, white's very dim. So these could be bad. Could just be the LED because I'm not driving them at the full sort of current they would have. Let's look at the other heads as well, see if we can find any that have even more obviously got LED problems. Because I'm thinking these sensors, I mean the discs are not dirty, there could be a problem with one of these sensors or more of them. But it could be some sort of cumulative problem with the LEDs, because I'm pretty certain, in fact I'd say definitely, this can sense the LED current, and if it didn't like it, it could just tell the thing to shut down. This thing is so large, it's difficult to get it under the camera for you guys, but this one looks better actually. Yeah, that one there, that first one doesn't have like a burnt mark, the other one does. Let's test this as well. I'll have to unplug it no doubt. And as I'm doing this, I'm getting a better idea of the way this is laid out. So there are actually 4 of these connectors on here, each one with 8 wires. So I'm confident now in actual fact each one is for one of the lamps. There's 4 lamps, so I've disconnected the other 2. So this board, I'm pretty certain this is just the LED driver. And then the board here, and there's another one down here, which look identical. They must control both axes of movement for lamps, 2 lamps on each board, okay? So we're getting a better idea of how all this is interconnected, which is always a good thing. Let's try this LED. Red is nice and bright. Yeah, you can see it. Green is nice and bright. Blue is dim. White is dim. So that may just be how these LEDs are, or the blue and white segments fail. Right? Yeah. Other one. Oh, red's good. Green's good. Blue is particularly dim on this one. And white also. Okay, one more. And I can get to this one while that's still on, so save a little job there. Right. Yeah. Oh, the blue is much brighter on this one. You see that? Let me see if I can get it on the camera better. In fact, I'll take this off just so nobody can say it's an optical illusion, yeah? Right. Red. Green. Much brighter. And the white is also much brighter. I think that tells me something. And what it tells me is there's a big difference on that last one, LED. I wonder what would happen if I power this up without the LED lamps plugged in. Does it say something on the display? Well, we're going to find out. So let's do that. Just check all the wires are not. Yeah, they're fine. They're not touching anything. It's good. Right, let's power this up without the lamps on. Beam rest. It all resets. This one's, yeah, it's in the right position. And it still says beam rest. Just give it some seconds. It says DMX mode, then beam rest again. Well, that's what it was doing before. It's just a bit longer this time. And then you have to wait about 10 or 15 seconds. Apparently, you should be able to get into the menu. Okay. That first square, which is the red one, looks like a white colour. Okay. That one, which is the blue one, looks very darkened. Same with this one, but on this one, the red LED also looks darkened, the blue very darkened. This one, yeah, you can see like a mark in the middle of that and that. And then the one that lights up properly is this one. And we can see there's no burn marks, yeah. Okay, so I've tried a couple of things actually. I tried just connecting this good LED, or looks good, and disconnecting the other 3 to see if anything changed, but the behaviour is exactly the same. So I've now reconnected all of them without the Fresnel lenses on, which want a damn good clean, by the way. I think you can see what this is doing, so I'll tell you because it's only there for an instance, but you'll see this one flash white. These two will flash like a yellowish colour, depending how well my camera can pick this up. The other one, well, I can't zoom out far enough to show you all of these, okay? But it does the same as these two. So let's just try this, you'll see it. Ready? Did you see that? This probably looked more blue to you, but... Okay, again, so this one looks on the camera more bluish white. It looks more white to me. These more yellowish, okay? So that tells me that the LEDs are failing at the normal drive current, which is a better test than what I was doing with a multimeter. And because the controller can control the heads, you saw the flash again there, okay, it would strongly suggest what's happening is that the communication, we know we have it from the panel on here, which is SPI, goes down to this driver board, okay, and the driver board is basically reporting problems with the lamps because the current either overcurrent or undercurrent when it tries to switch the LEDs on. The actual LEDs, you can see they soldered to these little boards which say XY167, okay, and that is screwed and also glued or heatsink compound to the heatsink. I actually asked the AI again, just out of interest, what it thought of my hypothesis that is the problem, and this is also based on the fact that normally speaking there is only one fault. Also, both of these units, which came from the same place and will be the same age as each other, have the same issue, and I'm confident even without spending the time I'm going to find the same one or more burnt LEDs. The reason the blue and white fail first, by the way, apparently is because they run at higher temperatures than the red and green LEDs. So I mentioned I asked the AI, my friend these days, and it suggested that these emitters, LEDs, are still common. You can buy direct replacements or choose equivalents on AliExpress, eBay. LED suppliers don't have to match the XY167 code exactly, okay. What matters is the pinout and physical layout. So I have some 12 watt LEDs here, but they have the wrong pinout. And you can't, if you're thinking, okay, we'll put a 12 watt on for now and see if this works. But bear in mind that the red LED has a much lower voltage drop than the blue and white, and the green somewhere in between, okay. So if I were to fit those, because the pinout is different, the colours would be different, and I would be driving the wrong LED from the wrong driver channel. So more likely they just won't work, or have the same sort of overcurrent or undercurrent issues. And worst case, I could actually burn out something on the driver board because of the unexpected voltage drop, of the LED. So I need to get the ones in the right order. Usually cost £2 to £3 each. Yeah, the grid just tells you how to remove that and how to do that. And as I say, only one fault at a time. Yeah, this makes sense. We all know this. There's normally only one fault. In this case, LED burnout fits perfectly because, as you say here, all the motion and display logic works, but the MCU halts and beam rest because one or more LED channels fails its current sense test. And this also explains why both of these things have the same problem, I would say. Yeah. So I'm having some problems finding the correct pinout or even the correct shape. One possibility, actually I should have thought of this before, I have some 12 watt ones, would be to just change the order of the wiring. So you can see this one is blue, red, white, green, whereas mine is red, green, blue, white. Okay, the polarity is correct. So one option would be to fit a type something like that, and then change the order of the wires here, just solder them into the positions I want, okay, to match that LED. So that's another possible way we could fix this, but I'll keep on looking to see if I can actually find anything more directly compatible. Well, it looks like the LEDs I have available from AliExpress are no more, or for that matter less, compatible than the ones I already have, which are these, okay. So I have a whole bag full of those. So what I'll have to do is fit some of these ones, let's give it a go, and then change the order of the wires so the right colours light up. So we can see this one is red, green, blue, yeah, not very good, white, okay. And the other one, well, depending on which way round it goes, let's just figure it out. So in the same direction, same pins, blue, red, that is, white, green. Okay, so that's the pinout of the original one, and that's the pinout for the replacement ones. And just so I know which way round I have these, we can see that inside there is like a square LED there, and this is a small one in this corner, and this is like a yellow colour. Okay, and this one's like a red colour. So from that I can get the orientation correct of this. There's no other particular way that I see on the package to know which is pin 1. These have a little contact under there which you could solder down. You could probably use heatsink compound. Let's take this one off here and see how that is fitted, if it has a pad underneath. It probably does. I'm interested to see if it's soldered. I'm sure some of you have noticed that the colour of the wires doesn't match the colour of the LEDs. Okay, and you may wonder, because I wondered, has somebody been messing with these? Have they got them the wrong way round? There's no way really I can tell that. Well, maybe not no way. Probably if I look at the driver PCB, the red one will have a different resistor, a current sensor or series resistor, to the other 3, because that is the one with a much lower voltage drop than the other. So that may be able to tell us. I thought let's have a look at the other one, but the other one has completely different wires. So that has like yellow, brown, blue, red or something, and blue, orange, red, you know, different colours altogether on either ends of the only one I took the cover off. So honestly, there's no real way easily to tell if somebody's been messing with these. The best I can say is, let's fit it this way around and see what happens, yeah? The best way to do this would be with a hot plate, yeah? But the hot plate I have, the small one, I actually let Carlos have it. So this is a Corda 853B hot air preheater. And this bit of metal here, this is actually based off an old, or part of an old soldering iron stand. Okay, so this will warm up quite nicely. It may actually warm up enough to unsolder it without hot air. Let's add some flux, because it can't do any harm really. Okay. One problem here is that this thing's actually going to move around. Okay, so it may be difficult to hold hot air and the tweezers at the same time and get that off from there. Let's see how warm this is getting. Over 100, so I'll turn the heater up. Let's see if we actually can unsolder it this way. It will certainly be a bonus if we can do. I'll turn it up to maximum. Oh yeah, look, it's off. Okay. I'll just set that to cool. I'll take the PCB off now. If that worked okay, then we'll use the same technique with the other ones. It looks like, yeah, this has a pad, but I'm not sure it was actually soldered underneath. Yeah, it looks okay. There's a good argument for resoldering this while the PCB is hot, but it warmed up pretty quickly. I need to unsolder the other ones anyway. Let's just clean this one up now. So a bit more flux. That was a soldered pad by the looks of it. Leaded solder. Add some of this, it helps. Okay. Braid. Okay, that looks pretty good. So soldering the replacement should actually be a bit easier because I'm going to use leaded solder. You could try, for example, adding some solder and then the same way I did it before. What I think I'll do with this one, I'll get a little bit of solder, just a little bit onto the back of this if I can, or certainly a little bit on that pad, and I'll actually solder the legs on and then put the thing back onto that hot plate and let the solder melt, and the idea being that the solder underneath will then also melt. Okay, so that's not an electrical connection, it's for thermal transfer. Can we get a bit of solder onto that? I'm not sure we can easily because of the shape of it. Okay, let's go this way. So flux again. Okay. You see, this will actually be wider, so it'll go to those pads, but that really isn't a problem. I don't think so. We'll find out. We can test it afterwards. Okay. Warm it up a bit. I should put it onto the metal thing, really. Okay. Bit of solder. That's nice and flat, or it was. There, nice and flat now. I'll add a little bit of solder to one of the pads in this corner. Okay, that one. And then I should be able to slide the LED or drop the LED onto that so it'll hold it in position, then solder the other ones. Okay. Yeah, I think that'll have it fixed down. Yeah, okay, now we can solder the other pins. Okay, go with this corner. In fact, I've got two of them really, that's okay. Should be enough solder on the end, but a bit more on the tip. Okay. Right. What I'll do now is repeat the process with the preheater so the solder melts. I see I have a bridge, by the way, there, so we can deal with that now. Okay, right, preheater, and of course a bit more flux. Yeah, you can clean this off afterwards, but it certainly won't hurt. Okay, and we'll warm it up. We'll see the solder melt, so we'll know when we get there. Okay. Yeah, can you see that? It's like changing colour. Okay. I'll soon know if it's melted even without touching it with the tweezers. Not just yet. So not yet. We should actually see that solder flow a little bit, in fact, when it does, okay, visibly. There, do you see it's moved just a little touch? Okay, so solder has melted. Right, turn the heater off. Okay, so let's test our LED. Blue, red, white, green. Okay, so that's good. I'm happy with that. Looks quite, yeah, flush down there. Okay, so let's now repeat that process with the other three, which I'll do off camera because you've seen it once. It's the same. And then we'll fit these back onto the light fixture and see if it actually works now. Okay, I've done 3 of them now, so here's another one done. We'll test them in a minute. This is the 3rd one. Actually, that is the 3rd and the 4th one, because this was the 2nd one. And what happened with this, after I melted the solder, I picked it up to move it away from the heat to put the next one on, and I dropped it. And then you can see in dropping it, it's actually moved. So I may as well see if I can reposition this. If I can't, well, I have a whole bag full of these things, so not a problem. I can just fit another one or resolder this one and test it again. I can remove it, but the PCB itself won't be harmed by this heating. These are aluminium PCBs, okay? These run hot in normal operation. So let's melt this one again and see if we can actually position it. I'll try and hold the thing still. If this all goes tits up, we'll use that phrase, okay? Then I'll just put another one on, or take it off and redo it. So let's see. It depends whether I can actually move this just enough. Yeah, there, do you see? That looks good. So we'll let that one cool down, and now let's test them. Yeah, that's working fine. Red, white, green, so that's good. Blue, red, white, green. Okay, no shorts or anything. Last one, which is the one that I dropped. Yeah, still working. Blue, red, white, green. Okay, so I just need to put these back onto their heads now, rearrange the wires to match the order of the colours on here. Then let's see if these work. Okay, so we have all those replaced. Okay, let's just see what this does now. Well, they all flashed white. Yeah, they've all reset. Should do a second time apparently. It says DMX mode. But I can't get into the menu still, it just sticks on that. Okay, so without doubt they needed changing, and we can see they're all white now, but it hasn't solved that problem. So the next thing I need to do then is to get a DMX controller and see if I can actually talk to this. Hope you enjoyed that anyway. We did some useful repair I think on this. They would have had to be changed anyway. I just hope now I can solve this problem, but I won't do the same on the other one until that is sorted. Okay, thanks for watching, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.